Hello, I'm Guan Chen. It's my turn to introduce the app. And first, we will see this screen, and this is how our app looks like, and it's our design. And second, we will see how our code how we cope with the signal and signal. And this Java this class contains the main activity, and most of the activity contains the Bluetooth parts, and so we should move to the middle of our code and find this. And this is the second part. This uh, this is when the sensor of the cell phone is changed, is updated, and this function will be called. And if the is the accelerator meter is called, and we will do the following task. And since the acceleration is composed of our handshake and the gravity, so we should extract our handshake's acceleration out of the sum of the acceleration. So the first one is we will use an high-pass filter to extract the signal. We will subtract the signal now to the signal before, and then we will get the real acceleration, and that's our first thing to do. And then we will get the true acceleration. Then we can store the true acceleration into the arrays, and that's it. And after we store the signal into the right place, then we can start to do the FFT. And this is the third part. And the third part is the FFT part. If we have gathered the data for 1 second, then we will feed the array the data into the FFT and get a complex number. And we will find the absolute value of the complex number and find the most significant part of the FFT. Then we will use the frequency as to define the speed of the car. And then we have find the speed for the car. Then we should send the signal to the remote car, and that's the following do. And that's the accelerator meter do. And besides, there's another sensor, and it calls the rotation. And we will use the rotation of our cell phone to define the rotation to define the direction of our motor car. We will use it to we wish our motor car to go as our cell phone's toward. And that's the part. And this is the part of our app. And then we can see our Arduino part. And this is our Arduino part. The Arduino is mainly coped with the task of the Bluetooth and the 3SS sensor. And when we do our task is there. It's mainly on the moving function, and we will use it to make the car to the direction we wish, and the code is there. We have write some statement to do this, And this is the Arduino part 2. And finally, we can see our PPT, and this is our first slide. And that's our 3 members in the project. And that is our hardware and software. And that is, we have said this, so I will quickly, and this is our final results. And the first result is we have removed the gravity of the cell phone to obtain the signal we want. And this is the z-axis of the raw signal. And we can see the magnitude of the signal is large. And that's because of the original acceleration made up to the 9.8 meter divided second square. And after the removal, we can see the magnitude of the signal is shrink, and it is centered at 0. Then we can see that the acceleration we don't want is reduced, and the signal we want is still there, and that's what we want. And that's from the chart we can see a magnitude, yes, and and that's the code, and we have seen from app the app, and this is the result too. We use the signal before and send it to the FFT, and we can see there's the most significant point in the graph, and we wish the car to use the frequency as its speed, and we also use a stretch to make the car will not move if the cell phone is placed still. And it's our algorithm, and it can be found in our app. And there's an FFT class, and this is the third result. And that's how we that's where we close to the true direction, and it's in our Arduino code. And thanks for listening.